This video is going to show you guys how to use the kinematics equations for various types of problems. So these are just example problems that you guys should have in your packets of what I gave you. So the first question here is an object accelerates from rest to a velocity of 22 meters a second over 35 meters. What was its acceleration? Okay, so we have an initial velocity of 0. We have a final velocity of 22 meters a second. We have a distance of 35 meters. And we need the acceleration. So we want to find an equation that has those four and only those four variables in it. Now I notice that the one variable I don't have is time, so I should probably use the timeless equation, which is v final squared, or the final velocity squared, is equal to the initial velocity squared plus 2AD. So the final velocity is 22 meters a second. Initial velocity is 0. I'm looking for the acceleration, and the distance is 35 meters. So we're going to square the 22 before moving forward, which is 484. Remember, adding 0 to anything doesn't do anything, so this could become 70a because the 2 and the 35 can combine. I divide both sides by 70. And I get an acceleration of 6.91 meters a second squared. Not too bad. So let's take a look at question number 2. Question number 2 says we have an object dropped from a height of 100 meters. How long is it in the air? So if an object is dropped, that means we are moving vertically. So our acceleration is negative 9.8 meters a second squared. And remember, if it's dropped, we have an initial velocity of 0 meters a second. The object travels downward 100 meters, hence why I put a negative in front of the 100 meters. And I'm looking for time. The only equation with those four and those four variables in it is the position versus time equation, which can be written as d equals v0t plus 1/2 at squared, or as it's written on the reference table, x equals x0 plus v0t plus 1/2 at squared. Okay, so we're going to assume my initial position is a 0 height, and from there I fall 100 meters. So that's negative 100 is 0 meters plus 0 meters a second times time plus 1/2 times negative 9.8 meters a second squared times t squared. Okay. Now, lucky for me, because I'm multiplying this 0 and this t, this goes away. If it didn't, like say I had an initial downward velocity, I would probably need to use the quadratic formula to solve for t. But in this case, I don't, because those first two terms are 0. So I end up with negative 100 equals negative 4.9, which is 1/2 times 9.8, t squared. Divide both sides by negative 4.9. And luckily for me, I get a positive number when I do that. If I didn't get a positive number, that's a good hint that we forgot a negative somewhere. So I got 20.4 is t squared. From there, I have to square root both sides. And that gives me a value of 4.5 seconds for a time. So it took 4.5 seconds for this object to fall 100 meters. Okay, let's take a look at number 3. An object has an initial velocity of 5.5 seconds. It's then subject to a constant acceleration of 2.5 meters a second squared for 11 seconds. How far will it have traveled during the time of acceleration? Okay. So I have an initial velocity of 5.5 meters a second and acceleration of 2.5 meters a second squared. 2.5 meters a second squared for a time of, I already forgot, 11 seconds. Okay. And I need to know the distance. Okay. Now, before I know the distance, just a quick aside, notice how the velocity and the acceleration are both positive. This means the object is speeding up. Remember, if our velocity and acceleration are both in the same direction, so both positive or both negative, the object will speed up. If they have opposite signs, then the object is slowing down. Now, this equation, or the equation I'm going to use, is going to be the same position versus time equation that I used in number 2. But this time, this term here isn't going to go away because I have an initial velocity. So I have x equals 5.5 meters a second times 11 seconds plus 1/2 times 2.5 meters a second squared times 11 seconds squared. Most common mistake that students make using this equation is forgetting the squared here. Okay. So doing 55 times 11 to begin with, sorry, not 55, 5.5, gives me 60.5. Okay, doing the next term, making sure to square the 11 gives me 151.25. So adding those two together, we get that this object has traveled 211.75 meters. Okay, so now question number 4. A pump can throw a stream of water upwards 29.6 meters. What's the initial speed of the stream when it leaves the hose nozzle? Okay, so we have that the object has traveled 29.6 meters. Because we're moving up, we can assume that my acceleration is negative 9.8 meters a second squared, and I need to figure out the initial velocity. Now, at first glance, it looks like I don't have enough information to use any of my equations. But what I have to remember is that when an object is thrown straight upwards, it stops at the top, meaning the velocity when it reaches this 29.6 meters is 0. So I can use that as a v final of 0 meters a second. So that means I need to use v squared, v0 squared, plus 2ad. So I have a final velocity of 0, an initial velocity of an unknown value, that's what I'm looking for. 2, remember to use negative 9.8 meters a second squared, and the d is going to be positive here because it is moving upwards 29.6 meters. And I put the squared on the wrong spot there. Okay, so this is 0 equals v0 squared minus whatever 2 times 9.8, 2 times 9.8 times 29.6 is, so that's 580.16. So I'm going to add that to both sides, so I get 580.16 is v0 squared. The square root both sides. So I do that. And I'm 80.16, square root that. We get an initial velocity of 24.0865. Okay. Let's see. So let's take a second to expand on question number 4. Let's say I want to know the time, the total time in the air. Okay. So if I want to know the total time in the air, I could do one of two things. I could find the time it takes to get to the top and double it, or I could remember that symmetry is a thing. So the speed on the way up is the same as the speed just before it hits the ground, just in the opposite direction. So I could use the v equals v0 plus at. I could plug in a negative 24.08 meters a second as my final velocity, meaning this velocity here. My initial velocity of 24.08 meters a second, an acceleration of negative 9.8 meters a second squared times the time. Okay. So I'm going to subtract 24.08 from both sides. So 24.08 minus, or negative 24.08 minus 24.08 gives me a negative 48.16. It's negative 9.8 times t. Divide both sides by negative 9.8. 9.8 gives me a total time of flight of 4.9 seconds. Okay. Doing it the halfway, instead of using a final velocity of negative 24, I would use the peak velocity of 0. So I would end up using the same equation, just with 0 equals 24.08 is plus negative 9.8 meters a second squared. This is meters a second times time. Subtract 24.808 from both sides and then divide by 9.8. So that gives me a t half or a t peak of 2.46 seconds. So if I want t total, I just do 2 times t half. So 2 times that 2.46, and that gives me 4.92 seconds, approximately the same as the answer we got before. Okay. So a slightly different example that actually isn't one of those practice problems. Let's say I am on a cliff that is 50 meters tall, and I launch a ball straight up off the cliff with a speed of 10 meters a second, such that it's able to rise to some height above the cliff and then fall back down. Okay. Now let's say I want to know the time for a question like this. Okay. So my initial velocity here is 10 meters a second. Since it's moving vertically in the y direction, we have an acceleration of negative 9.8 meters a second squared. Okay. And my total displacement from start to finish, which is what that D represents, is a negative 50 meters. Yes, I do travel slightly farther because I travel up and back down. But from start to finish, I've traveled downwards 50 meters. And I want to know the time. Okay. So I need an equation with these 4 and only those 4 variables in it. So that gives me the position versus time equation. Plus 1/2 at squared, okay, where x minus x0 1/2 at squared is the displacement that I was talking about. So when I want to plug in that negative 50, I plug it in as negative 50 meters is v0, which is 10 meters a second times the time, plus 1/2 times negative 9.8 meters a second squared, t squared. Okay? Or you can think of it as the object. Okay, if you want to think of it like this, the object starts at a height of 50 meters and ends at a height of 0 meters. That still gives us a change in displacement of negative 50. So that would be perfectly fine, thinking of the question like that. If you want to say the ground is 0. Okay. Now, you'll notice that we have a t and a t squared, which makes life a little bit complicated because now we need to apply the quadratic formula. Okay, so in order to apply the quadratic formula, we need our equation to equal 0. So if we add 50 to both sides, we end up with this equation here. Okay. Now, usually when we have the quadratic formula, we have it in ax squared plus bx plus c format, plus bx plus c. So we have 1/2 times negative 9.8 meters a second squared, t squared, plus 10 meters a second, t, plus 50 meters. So that means this 1/2 times 9.8 is A, this 10 meters a second is B, and 50 is C. Now the reason why that's important is because we all know the quadratic formula is x equals negative b, in this case t instead of x, plus or minus the square root b squared minus 4ac all over 2a. So using the numbers that we have, b is net 10, so negative 10 plus or minus 10 squared minus 4, negative 4.9, because that's what 1/2 times 9.8 is. C is 50, all over 2 times negative 4.9. So this is negative 10 plus or minus the square root of 100. Now, lucky for us, it ends up adding, so we don't have to worry about complex numbers or negatives under the radical, because subtracting a negative number is the same as addition. So that's 10 plus 980, all over 2 times 4.9, which is negative 9.8. Okay, so then we have negative 10 plus or minus the square root of 1080, all over negative 9.8. Okay, now remember that plus or minus means we're either doing negative 10 plus the square root of 1080 over negative 9.8, or the negative 10 minus the square root of 1080 over negative 9.8. Okay? Now remember, we're solving for a time. So if we get a negative number, that's not going to make any sense because you can't have negative time. So when I do the square root of 1080, we get 32.86. So negative 10 plus 32.86, or negative 9.8. Well, since 32 is bigger than 10, I'm going to get a positive number on top, and a positive divided by a negative is a negative. So this one is not going to work for me. So that means I need to use the minus the radical. So negative 10 minus 32.86 over negative 9.8. That results in a negative divided by a negative, which will in fact give me a positive number, which is what I want because time always needs to be positive. Okay, so that gives me a time of 4.37 seconds. And you're probably thinking, Narc, that's terrible. Why would you ever have us do it? The answer is I probably won't ever have you do it on a test, but it is a good idea to know how to apply the quadratic formula when using kinematics equations. So that's the basics of how to use all of those equations. Okay, so the format that I followed for all of these, you'll notice that I first made a list of anything I could assume or was given. So I want to write out my assumptions. So that's things like, if I start at rest, my initial velocity is 0, right? At rest, my initial velocity is 0. To a stop, my final velocity is 0. And if I have vertical motion, my acceleration is negative 9.8 meters a second squared. And then I write out my givens. Then I figure out what my unknown is. Then from that list, so these three, I figure out what equation I need to use in order to solve. Then I substitute, of course, with units for full credit. And then I write out my solution with units. Okay. Now, really, this part is just our answer with units. It's not like you need to show me every algebraic step. All I need to see for full credit is your equation, your substitution with units, and your answer with units. This stuff up here is incredibly helpful, so I highly recommend it. Okay, so when you're stuck on a problem, how do you solve a physics problem? Well, like with most physics, you just make a guess. And that is the end of this video.